Hello everyone. This video is an introduction to templates. It is for the people who are not familiar with templates and to have them better prepared for the more advanced videos such as the STL series. If you are already very familiar with templates, you can skip this one and go directly to the others, because I will cover only the fundamental stuff about templates. I have a function square which takes an integer parameter x, and it returns the square of x as an integer. So in the main function I print out square 5, and let's run it. And it prints out 25. This is good. However, later on I want to print out the square of 5.5. It's a double, so this function can no longer be used because it only works with integer. So I have to make a copy of this function and change the type to double. And run it. So the first one print out 25 and the second one print out 30.25. This code gets our job done, but in a very inconvenient way. Suppose later on I want to print out the square of a long, and then square of a float, a square of complex. I have to make a duplicate of this square function for each one of the data type. This makes our code look ugly, and we don't want that. And this is why we need a template. With template, we only need one copy of the square function code. All we need to do is this: template type name t, and then instead of specifying the type as integer, we specify it as t. And in the main function, when I call square 5, I tell the compiler that this is the square function of data type integer, and this is a square function with the data type of double. And now if we run it, it still prints out 25 and 30.25. So when this function is invoked, t is replaced with int, and when this function is invoked, t is replaced with double. So this is how you use a template function square. Another thing to note is, with template function, you don't have to specifically tell the compiler the data type. The data type can be inferred from the parameter. When the compiler sees 5, it will infer that the data type is integer, and when the compiler sees 5.5, it will infer that the data type is double. So now if we run it again, it prints out the same thing. Template has a side effect called code bloat. Even though we only have one copy of the square function code, this square function and this square function are actually different square functions. In other words, they occupy their own space in the final program image. So if we use the square template function on a lot of different data types, the code size will be bloated. So much about function template. Now let's talk about class template. The arguments that we have just made for a function can also be applied to a class. Let's create a template class. It's called bow vector. And the bow vector has a big array and an integer of size, and a default constructor will initialize the size to 0. Push will push one item to the end of the array and increment the size. Print will print out all the elements in the array. And in the main function, I will do this. I create a bow vector BV and then push 4 items into BV and then print BV. Let's run it. And 4 items are printed out. And here I create a bow vector with the integer as the data type. So in the template code, the type T will be replaced with int. And I can use the same class bow vector for data type of long or float or short, any type I want. One difference between a class template and a function template is a function template can infer the data type from its parameter, so you don't have to explicitly tell the compiler what is the data type. But for class template, you have to specifically tell the compiler what is the data type that you are using. Now let's make the code even fancier. I have a get function to get one particular element and get size to return the current size. And then I define operator multiply for bow vector. What it does is it multiplies the elements of the 2 bow vectors one by one and use the result to form a new bow vector and return it. And in the main function, I have BV equal to square BV. So here I'm passing a template object as parameter to a template function. What this does is it will invoke the square function with the data type of bow vector, and it will return BV times of BV, and this will invoke the operator multiply that we have just defined for bow vector. And the operator multiply will multiply the 2 bow vector item by item and return a new bow vector. So what's get returned is a new bow vector that has the squared value of the original BV's values. Now let's comment out this one and then run it. So the squared BV will print out the squared value of the original BV's value. This is an example of a class template working together with a function template. That's all for today. Feel free to subscribe to my channel so when I post a new video you'll be updated. Or you can go to my channel's homepage and see what I'm offering today. Bye bye.